Welcome to the Databricks Skill Builder series. We're glad you're here.
Hi guys, welcome to the next episode of Introduction to Unity Catalog. My name is Diego Gomez and I'm a solutions engineer at Databricks. In the last episode, we set up a storage credential and external location to store our data. Now let's explore how to manage that data within Unity Catalog. To start with the first thing, catalogs are the primary unit of isolation within the data hierarchy, as you can see right here. Since we previously skipped adding a default location to the metastore, we will need to explicitly define where the catalog will be stored using the storage paths we created in the last episode. A good thing about catalogs is that they can be binded to specific workspaces in order to segregate access and streamline permissions management. This pattern is usually employed by following the software development lifecycle as you see right here, or even further by isolating through business units. Now, going into the platform, we're also going to be showing you how you can create these assets through SQL statements. In this case, in terms of permissions, this will completely vary depending on what role you have assigned within the platform. And this applies only if you're a regular user that's not an owner of anything. So in this case, you will only need grant create catalogs permissions on the metastore. In this case, we're granting it to a specific group. And this would be the clause and the SQL statement to create a catalog, and we have to define a managed location since we did not define the default location of the metastore for reasons that we explained within the last episode. Now, to discuss a bit about schemas, schemas are the second object of the data hierarchy. And before we even get into that, it's super important to understand the baseline concept that we will be using to design these schemas. So the medallion architecture is both a logical and physical data design pattern that can be applied at various levels within the lakehouse. It all starts with the bronze layer, which captures raw data from various sources. Then we have the silver layer, which involves initial cleaning and structuring of raw data. And finally, the gold layer contains refined, high-quality data ready for analytics. So first of all, schemas can either inherit the parent's catalog location, the one that we just defined in the notebook, or override it. With that in mind, the main focus when designing your schemas should be streamlining permissions rather than worrying about physical isolation. For example, let's say that we're going to be ingesting data from Salesforce and currently have 10 tables for each layer. So 10 for bronze, 10 for silver, and 10 for gold. If the data is going to be managed by a single business unit, let's say that would be the finance department, it might make sense to keep it all under a single schema and grant permissions to read and write to that business unit, as you see right here below. However, if you have groups like data engineers that will manage all of the layers, but others like data analysts that only require access to gold tables, going with the single schema approach that we see below will require you to grant individual access to each of the 10 gold tables. And in the future, if any tables are added, you will also need to manually add in those permissions as well, and this is not convenient at all. A better way would be to divide these schemas into each of the layers, having a bronze, silver, and gold schema. Now you'll only have to assign permissions to data analysts in a single place, and that being read permissions at the gold schema, and this will account for current and future tables. If we go back into our notebook, the only permissions that a regular user will need to create a schema will be grant usage on the catalog and also grant and create schema permissions on the catalog. As we can see right here, we can either inherit the parent's location, the one that was defined right here above at the catalog level, or we can override it and set it to a completely different container or even different path within the same container. And this is going to be super useful if you have any sensitive data, such as PII, that we need to comply with and regulate. Now to discuss a bit about tables, there's going to be two different types of tables. We have managed and external or unmanaged tables. Both of these can be stored on external locations. It's super important to not be deceived by the name. In the case for managed tables, Databricks will manage both the metadata and the data files, allowing the platform to optimize automatically these data files. On the other hand, external tables are better from when the actual data files are going to be accessed by external systems, this being other databases, other SaaS platforms, etc., with Databricks only managing the metadata, thus requiring manual optimizations. And the only differences between creating the two will be that the external tables require an additional location clause to define where this table will be stored. Going back into our notebook, we can see that we will only need grant create table on schema. And in this case, we will be working only under a single schema to prove that we can define managed and external tables under that same schema. So in this case, we can create the table if it doesn't exist. And then the external table, we will be defining the columns that it will have, in this case, an ID, which will be an integer, and a name that will be a string, and also adding the location clause for where this table and its files will be stored. Finally, we have volumes. Volumes are abstractions of Cloud Object Storage that provide users with access to a specific path within the Cloud Object Storage without granting direct access to the storage credentials or external locations. This setup enables secure file system access through Unity Catalog. Volumes can either be managed, with Unity Catalog managing the full lifecycle and layout of the data in storage, or external, with Unity Catalog managing access to the data from within Databricks, but not managing access to the data in cloud storage from other clients. If we go back here, we will be creating an external volume just to prove how you can use it and what the use cases for this would be. So we will be needing the grant create volume permission at the schema level as well. And this would be the clause used to create an external volume. In this case, we will be storing it under the same external location that we defined earlier under the volume raw path. And if we go ahead and use this volume to access the file system, we can see that we already have a couple of CSVs stored within the file system or within the Cloud Object Storage. This can be super useful. Let's say that we have to do raw data exploration, or we just want to store images or raw files within the platform while still enabling secure access to these data objects. And that will be all for the third episode. We thank you a lot for taking the time to watch this, and see you in the next one.